I will be discussing with a econometric problem, and that problem is very important for understanding of time series. And with respect to the stationarity and non-stationarity, for better understanding of these two things, this type of understanding you should have a clear idea. And what is that? It is nothing but the correlogram. It is nothing but the autocorrelation function. It is nothing but ACF. So, what is the autocorrelation function? Autocorrelation function, it's nothing but a plot of correlation coefficient with respect to time lags. With respect to lags, the plot of the correlation coefficient, you can have the ACF or correlogram. You know, if in the autocorrelation function, or you can say, if you take a autoregressive structure, that is AR1 process. What is the AR1 process? AR1 process is nothing but YT, look at the blackboard, YT equal to A0 plus A1 YT minus 1 plus epsilon t. This is the AR1 process. Okay, this is the AR1 process. Why it is the AR1 process? Because the lag structure of the dependent variable is YT minus 1. So the first lag of the dependent variable is used in this equation as a explanatory variable. So this type of equation is the autoregressive process. Now, if this part A1 is less than 1, then the process will be stationary. And if it is greater than 1, then the process will not be stationary. It is explosive. And if the A1 is 1, it means there is a unit root. Unit root means the data series, the data is non-stationary. So, how could you understand the non-stationarity and the stationarity of this series? By just seeing the plot of the correlogram or ACF function, you can have an understanding whether the data is stationary or not. So in AR1 process, A1 should be less than 1 if that series is the stationary. Now, the plot of the correlation coefficient can be found in a correlogram chart, and in the correlogram chart there is a autocorrelation correlation coefficient with respect to the respective lags. And if the data is stationary, then the correlation coefficient will be very minimum. And it will not exceed the two-side bounding line. And within the bounding line, the correlation coefficient will exist, and it will be very low numbers. Now, look, here is a question, and that is the for AR1 process, a necessary condition for stationarity is mod A1 less than 1 justify. So we have to justify in case of stationarity, the AR1 process, in the AR1 process, the coefficient of the yt minus 1 should be less than 1. Now, how could I justify it? Look, we know that the correlation coefficient is equal to the covariance between the yt and yt minus s. So yt minus s, yt at period suppose 2 and t minus s, and s is 1 and it is 2, so t minus 2 minus 1, that is 1. That is s is the lag period. Now variance between yt and variance of yt. So correlation coefficient between is nothing but, in case of autoregressive structure, is the ratio between the covariance of yt minus 1 and variance of yt. Now you can write this in such a way, gamma s and gamma 0. Okay, so what is the gamma s? So we can write in such a way that gamma s equal to expectation of yt minus mu, it is the mean and mean of the series, yt minus s minus mu. Okay, and what is the gamma 0? Gamma 0 is equal to expectation of yt minus mu, expectation of yt minus mu whole square. Okay, so now we can put this value here and this value here, and we can proceed in such a way. But what does these values actually mean? Now we understand that, as you know, yt equal to a0 plus a1 yt minus 1 plus epsilon t, and now we replace t by 1, then we can have y1 equal to a0 plus a1 y0 plus epsilon 1. In the same way, if I put 2 in place of t, then y2 equal to a0 plus a1 y1 plus epsilon 2. What is the value of y1? Equal to a0 plus a1 a0 plus a1 y0 plus epsilon 1 plus epsilon 2, equal to a0 plus a1 a1 plus a1 square y0 plus a1 epsilon 1 plus epsilon 2. Now equal to, this is the value of y. Okay. Now for y3 equal to we place 3 here, y3 equal to a0 plus a1 y2 plus epsilon. And what is the value of y2? We put the value of y2 here, equal to a0 plus a1 third bracket. This whole things I will put here. So a0 plus a1 plus a1 square y0 plus a1 epsilon 1 plus epsilon 2 third bracket. In place of y2 we have placed this, and now plus it would be 3, so epsilon 3. So now you can simplify this in such a way, equal to a0 y3 equal to a0 plus a0 a1 plus a0 a1 square plus a1 cube y0 plus a1 square epsilon 1 a1 square epsilon 1 plus a1 epsilon 2 plus a1 epsilon 2 plus epsilon 3. So in this way we can proceed further and further. So in period T we can write in such a way that after number of periods, that is up to T, we have this equation. At period 3 you know what we have found. Now in this way, if we proceed for T, then we can write in this way. A0 and then 1 within bracket, 1 plus a1 square, and plus a1t, t to the t is the power of a1 and y0 plus epsilon I equal to 0, t minus 1, a1i epsilon t minus I. Now, if we take the expectation of this equation, that is the mean, you can have yt equal to a0 1 plus a1 plus a1 square, and we can write in such a way that the expectation of this and plus, and we can write in such a way that a1 t expectation of y0, and you can write this thing in another way, that is a0 summation I equal to 1 to t minus 1, and here we have plus dot dot dot, here we have plus dot dot dot, and a1 I, okay, a1i. So I equal to, here is 0 to 0, I equal to 0 to t minus 1 a1 I plus a1t y0. This is the expectation of yt, because if you put 0 here, then the part is 1, so 1, and then if you put 1, then this value will be a1 only, a1. In this way you can find the by putting the different values of I, and you can get this equation. Okay, so this is the mean. Now for example, if you take the time is for infinity, and we can say in this way, if t tends to infinity, and we can write a1 less than 1, mod of a1 less than 1, then what is the result? So from this we can have yt equal to, and this part is nothing but a0 within bracket 1 plus a1 plus a1 square plus dot, and this will be, if a1 power t is infinity, then this part will be 0, and we have only this part plus summation I equal to 0 t minus 1 a1 I epsilon t minus 1. Okay, so now if you take the expectation of it, then expectation of yt is nothing but this thing. Okay, a0 summation I equal to 0 to t minus 1 a1 I, and this part will be the 0, because expectation of error is 0, so this part is 0. So expectation of yt is this thing. So what is this? What is the value of this? So you can write in this way, that expectation of yt equal to a0 by 1 minus a1. This is the expectation of yt. So by using the simple mathematical formula, when a1 less than 1, we can have this value. Okay, a0 1 minus a1, 1 minus a1. Now we put this value in the equation, and we can get in such now. Now you know the value of this part. Okay, so value of this part is nothing but a0 by 1 minus a1, a0 1 minus a1, and this part will be 0 if we consider t tends to infinity. So what remains? Plus summation I equal to 0 t minus 1 a1 I epsilon t minus 1, t minus I. Okay, and where a1 mod less than 1, where? Okay, so yt minus a0 by 1 minus a1 equal to summation I equal to 0 t minus 1 a1 I epsilon t minus I. Okay, so this is nothing but the mean. This is nothing but the mean. So yt minus mu equal to summation I equal to 0 t minus 1 a1 I epsilon t minus I, t minus I. So this is the yt minus mu, and if you take the square of it, then you can find the variance. And this variance has been used in the denominator of the correlation coefficient, if you can remember. So yt minus mu whole square equal to summation t minus 1 I equal to 0 to t minus 1 a1i summation epsilon t minus I whole square. Okay, so now we simplify this in such a way that now I take the expectation of it yt minus mu whole square, because this is the variance, and that you can have in the denominator of the correlation coefficient, and this is the value of the expectation of this part. Okay, now if we and here t tends to infinity, so we put infinity here, and now expectation of epsilon t plus a1 expectation t minus 1 plus a1 expectation epsilon t minus 2 plus dot whole square. Okay, dot whole square, and you can find the square here and epsilon t minus 1, and in this way we can simplify this. Okay, now if you know the expectation, you should remember that expectation of epsilon t is equal to 0, and expectation of epsilon t comma t minus 1 is also 0, and so it means that the mean and the covariance of the error part is 0. So ultimately we have equal to sigma square. Ultimately we have sigma square 1 plus a1 square plus a1 4 plus dot. Okay, so equal to sigma square 1 minus a1 square, and this is the value of this part. Okay, it is nothing but the variance. So variance is this, and what is the value of the covariance? And covariance is, in the same way, the covariance is sigma square covariance that is placed in the numerator of the correlation coefficient, and you can write in this way yt comma yt minus s, and it is nothing but sigma square a1 s by 1 minus a1 square. Okay, 1 minus a1 minus square. So now this is the covariance between these two. So what is the correlation coefficient? Correlation coefficient, as we know, that the covariance between yt and yt minus s, and the value of this is a1 is 1 minus a1 square divided by variance. The value of the variance, what is the value of the variance? Value of the variance is sigma square by 1 minus a1 square. Okay, and by simplifying it, sigma square a1 is by 1 minus a1 square. If we multiply 1 minus a1 square by sigma square, now sigma square, and this sigma square and this sigma square is cancel out, and this is cancel out. So what remains? Remains is a1s. So rho is a1s. So what we have found? We have found that ultimately we have found that rho equal to a1s. Okay, so now look, if a1, as we have mentioned, that less than 1, so if the power of a1, that is s is 1 comma 2 comma 3 dot 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 dot, then you know, if it is 1, if it is the power of s is 0, then it will be 1. Okay, so rho s. Okay, so rho 0 equal to 1. Now if rho 1 equal to a1 and rho 2 equal to a1 square and rho 3 equal to a1 3 and rho 4 equal to a1 4, and in this way rho s equal to a1s. So you can have a proper understanding on the basis of the correlation coefficient, that if the power of the correlation coefficient, that is the s is nothing but the lags. If the lags are increasing, the value of the correlation of coefficient has been decreasing. Okay, so in case of stationarity series, the a1 should be less than 1, and the correlation of coefficients values will be very low and negligible, and that values are not significant. So in case of non-stationarity, it may be a1 may be 1, but in case of stationarity, a1 should be less than 1, and if a1 is 1, then there is a non-stationarity. So this is the understanding of this analysis, that for an autoregressive structure, that there is a coefficient of the lag dependent variable should be less than 1. And that's all from my side, and thank you for enjoying the lecture.